Hi friends, today we will explore how to create a structural column from scratch using the dedicated Revit structural column template. To kick things off, we will start with a simple column inspired by a Pinterest find. This initial column will feature a fixed extrusion running from bottom to top, forming a profile with equilateral sides. Let's start a new family. We find the correct one, the fam column structural template. This family template comes equipped with some predefined parameters and built-in functions that we will explore. We start by editing and adding two parameters, one for thickness and another for width. You make it the cross width, place it in the dimension category and make it instance. We create a new parameter which is the cross thickness, make it instance. Okay, the depth we won't be needing it, so we delete it, apply it, nice. We set up our reference planes for the thickness of the cross. And now we have set up our reference planes. We place out dimensions. This is for thickness, make it equal around the center line, allowing for uniform adjustment of the thickness on either side. We change the scale and do a little cleanup before we connect our parameters to the dimension lines. So let's move on and construct our geometry by utilizing the extrusion tool. Personally, I prefer to position these elements adjacent to the reference planes rather than directly on top of them. This approach offers better control when aligning the geometry to the reference planes later on. So let's go on with the tedious alignment job. We connect it to the width of the cross section, the profile. We connect it to our thickness reference planes. There we go. We press OK and we go into the parameters and we flex the model to make sure it works as intended. An error has occurred. Forgot to align one line during the tedious alignment process. So this serves as a reminder of how crucial it is to continuously flex the model to avoid unpleasant surprises down the road. We also connect the dimension line width with the parameter width. We do little flexing again and now seems to work as intended. We're moving to the front view. We will align our extrusion with both the built-in structural column's upper reference level and lower reference level. These reference levels play a pivotal role in connecting the column to an elevation level when it's eventually loaded into the main project, as we will see in just a few moments. Associate the material with the material parameter that will give the end user the opportunity to change the material for our column. We save it as simple beam. We go to manage and do a little purge before loading it into our main project. In the properties for our column, we see the built-in parameters. We have the base level, which corresponds to the lower reference level in the family, to which our column is aligned, Additionally, there is a top level representing the upper reference level. It's worth noting that you have the flexibility to offset the column from both the base and top level as needed. We do have the option for rebar cover, which means we haven't defined our column as a steel column in the material model behavior option inside the family. We open the family and go to the family category for steel. We change the model behavior to steel. Press OK and we load it into the project once again. And you see the rebar option is gone. We do a little flexing of the column and it seems to work just fine. Now let's have some real fun with this advanced column I also found on Pinterest. It does have the profile from the first column, but here's the kicker. It gets slimmer the closer to the top you get. Also, we do have the wood details halfway up the column, which also gets slimmer near the top. And this is a perfect job for the blend tool. We start a new family. This will also be a structural column family template. Let's see if we can find it. Yeah, there we go. We start with reference planes for our thickness of the plate. We dimension it. We scale it down so it's easier to see the dimensions. For our thickness, we do the same here. Like that. We create our reference planes for our profile at the top of our column. Remember, the blend has two different profiles, so this is for the top. We dimension it once again. Just a little bit tidying up. And the other side. This looks a bit messy with all the reference planes, but stay with me guys. It will all make sense when you start modeling the geometry. We go into the parameters and start creating the different parameters for our column. This will be the cross width and this will be for the bottom. It will be in the dimension category. We create a new one, or we edit the depth one. This will be the cross width top. Place it in dimension. We make it instance. Create a new one. This will be the cross section thickness. Okay. We place out 15 for the thickness, 400 for the top. We associate dimension lines to the parameters. Thickness to thickness, yes. It's a little bit small, so we adjust the thickness to 50. It will be easier to place out the geometry. Now it's time for the geometry using the blend tool. The blend tool blends two profiles together. For example, if you sketch a large rectangular and a smaller rectangular on top of it, Revit blends the two shapes together. In our case, there is a big cross at the bottom and a smaller cross at the top, and they will blend together. We start with the bot cross section or bot profile section. And it's really important to stay concentrated. It's easy to mess it up with all the reference planes. I will fast forward a little bit. Next is the top. I'll do the same thing here. The only difference is aligning it to the top reference planes. We again do a little fast forwarding. We press OK and we do some flexing to see if everything works. We change the thickness. Yeah. We try to change the bottom. Works, and the top. Yeah. The reference planes is moving, the geometry is moving along with it because of the alignment. We go to the front view and connect them to the upper and lower reference level, which we remember is the built-in parameters that represents the base level and top level in the family. And they are now connected to the levels. We go to the 3D view. Then we add the material for our steel. This will be an instance parameter. Place it in the material category. OK, apply, OK. We press the column and associate the material with the parameter. Let's again check our Pinterest advanced column to see the wood details. And this will also be a blend, but it is a distance from the top, which will be a parameter. So the distance from the top of the wood details will be a user parameter. First, we draw up the reference planes for the top section of our wood profile. And this profile will not be the same as either the steel top profile or the bottom profile. This will have its own profile. We proceed by adding the parameters for the wood part. This is the tree height and it will be the distance from the floor or bot reference level to where the tree ends, and it will be a user defined height. As of now we set it to 2000. We add a length. This will be actually a reporting parameter for our total length of the column. A reporting parameter extracts a value from a geometric condition, that will be our levels, and uses it to report the data. As of now it's grayed out, so we can't edit it, it just report. We will use this value in a formula to determine the width of the top tree profile in the blend geometry. We add a tree distance. This will actually be the width of the top of our blend wood column. We add a ratio parameter between the reporting parameter length and the user editable tree height. The data type here needs to be a number, since the calculated value in the formula will be unitless. Type in the formula for our ratio, which basically is tree height divided by the reporting parameter length. Division by 0. Okay, so we can't divide anything by 0. We haven't actually associated our reporting parameter length to a dimension line. We go to front view and we set up the dimension for the total length of the column and associated with the length parameter. As you can see, it's now have a reporting parameter of 4000. We do it again, tree height divided by the length. And now we have a ratio of 0.5. We edited tree height to 2500 to test, yes, and the ratio changed. Next, we type in the formula for our tree distance or tree width. This will be cross with both minus parenthesis cross with but minus cross with height parenthesis. We multiply this with the newly created ratio, and this will give us the tree distance or the width. Let's try to explain the formula with a graph. We have the length on our x-axis and tree distance, which is our width of our top tree blend profile, at our y-axis. When the length is 0, the tree distance is the same width as our bot steel profile. When the length is the same as the total steel length, the tree distance is the same as our top steel blend profile. The 250 and 750 value might change depending on the user input, but for the values that is typed in now, this is correct. When we type in a tree height that is between 0 and 4000 millimeters in length, the tree distance will be somewhere between the 250 and 750 value for the typed in values now. So I do hope that made a little bit of sense. We continue with the connection of the parameters to the dimension lines, and we do that in the lower ref level. This is the tree distance, the calculated one, using formula we just created. Next up, we draw the geometry. Again, we use the blend tool to create the profile for our wood. We align it. And create a radius using this tool. Nice one. We edit the top. Basically we do exactly the same, aligning it to the tree distance. We have finished up the top and bottom profile. We press OK. We go to the front view to connect it to the tree height reference plane we just created. Align it. We go to the 3D view to see how it works. It looks pretty neat. We open up parameters and create a material for the wood. This will be instance, and we place it in the parametric data type. Press OK. We press the wood geometry associated with the newly created wood material parameter. So we go to the family types for little flexing of the wood geometry. We change the tree height, and you see the wood adjusts, and it's aligned with our steel blend. We change the cross with bot, cross with top, and it seems the geometry is working as we wanted. Yes, we go to the lower ref level again, and we will draw up the exact same geometry for all our sides. I will fast forward once again. We are finished with the alignment of the geometry to the reference planes. We go to manage, we do a quick purge before we load it into the main project. We place it out and we'll see how it looks. It looks a bit gray at the moment, so let's change up the material. We search for some steel material that we can apply for our cross-section steel column. We go to wood and we expand the home button to find some wood materials like this birch. We place it out and apply it to the wood. This is still gray. Something is wrong. What can it be? Let's see. We turn it around and we can see that one side have the material birch, but the three others have not. So this means we have forgot to associate the geometry for the three other sides to the material parameter. We do that and we load it into the project to see if something changed, and it changed. That looks just like the Pinterest picture shown earlier. We mark the model and we do some flexing. This concludes this monster tutorial on structural columns. Thank you for watching, and remember, subscribe and like this tutorial. It will help me out very much. Thank you.